In note 6.4, we're going to be talking about molecular formulas. To get into molecular formulas, let's talk about what a molecular formula is. So the definition of a molecular formula is that it is the actual formula of the molecule. In other words, it's going to tell us the exact numbers of atoms that are present in a particular molecule. Okay, the molecular formula can be the same as an empirical formula if we're talking about an ionic compound, or it's going to be some multiple of the empirical formula, which is going to be a molecular compound. So molecular formulas, again, can be the same as an empirical formula or some simple whole number multiple of it. Okay, so if we think back to our empirical formulas, remember empirical formulas are the lowest ratio, whereas the molecular formulas are going to tell us the actual number of atoms present. The molecular formula, again, is either the same as an empirical formula or some multiple of it, and molecular formulas can easily be reduced into empirical formulas. So an example of this would be as follows. The molecular formula for a compound may be C6H12O6. Again, this right here is going to represent the molecular formula. It tells us exactly how many carbon atoms there are, 6, hydrogen atoms there are, 12, and oxygen atoms there are, 6. Okay, the empirical formula of this molecular formula could be then, or would be, CH2O, which is giving us the ratio of carbon to hydrogen to oxygen. 1 carbon, 2 hydrogens to 1 oxygen. So again, our molecular formula is easily reduced into our empirical formula. The empirical formula gives us the ratio. The molecular formula tells us exactly how many atoms are present. The steps for determining the molecular formula are as follows. You're going to divide the molar mass of the molecule by the molar mass of the empirical formula to get what's known as the multiplier. Once the multiplier is known, then we multiply our empirical formula by that multiplier to get to our molecular formula. Okay, so the important thing to know is we cannot determine the molecular formula for a compound until we first have an empirical formula. So let's look at an example of this. Let's say we want to find the molecular formula of a compound where the molar mass of the compound is 60 grams and the empirical formula of the compound is CH4N. So this molar mass here, where it's given to us, this is an experimental value that's maybe determined in lab. Okay, and then notice we're also given the empirical formula. So the first thing we have to do is find the molar mass of our empirical formula. And again, our empirical formula is here, CH4N. So to find the molar mass, we're going to take the molar mass of carbon, which is 12.01, plus the molar mass of hydrogen, which is 1.01, times 4, plus the molar mass of nitrogen, which is 14.01. When I add this all together, I end up with a molar mass of 30.06 grams per mole. Okay, now that I have that, I am going to take the mole weight, or the molar mass, by the mass of our empirical formula, and we're going to divide it out. So the molar mass, this should say molar mass, is 60, okay, and that's given to us from the problem, and the mass of the empirical formula was 30.06. Okay, if I divide this out, I get approximately 2. This 2 here becomes the multiplier. And now I'm going to multiply everything in my empirical formula by 2. So remember, my empirical formula was CH4N. Okay, I'm going to multiply all of that by 2. And so the chemical formula, or my molecular formula, is going to be C2H8N2. So the actual formula for the molecule, if I were to look at it, would show me that I have 2 carbons 8 hydrogens and 2 nitrogens. And again, I used the molar mass of the empirical formula with the molar mass that was given in the question. I divided them to find the multiplier and then multiplied everything to get to that molecular formula.
What's that?
We're going to look at one more example that's a little more complicated. So in this example, it tells us the molar mass of the compound is 92 grams per mole. Again, this is that experimental value that was probably synthesized or determined by synthesizing this compound in lab. It says analysis of a sample of the compound indicates that it contains 0.606 grams of nitrogen and 1.390 grams of oxygen. We need to determine both the compound's empirical and molecular formulas. So if we think back to how we determine the empirical formula, we're going to take the masses that are given and first convert them into moles. So I know the molar mass of nitrogen is 14.01 grams per 1 mole. Again, I have 0.606 grams, and I want to figure out how many moles that is. Okay, when I solve for x is going to equal 0.04 moles of nitrogen. Okay, I'm going to do the same thing for my oxygen. So the molar mass of oxygen is 16 grams per 1 mole. I have 1.390 grams. I want to figure out how many moles that is, and if I divide it, I get 0.08 moles of oxygen. Okay, once I have the moles of each, I can determine the ratio by dividing by the smallest number of moles. So I have 0.04 moles, 0.08 moles, so 0.04 is the smallest. So that gives me a 1:2 ratio, which means the empirical formula of my compound is 1 nitrogen to 2 oxygens. Okay, so step number 1 was determining the empirical formula. The empirical formula was N2O. Now that the empirical formula was known, and again that was NO2, now we're going to determine the multiplier. And to determine the multiplier, we first have to find the molar mass of the NO2, which is 14.01 plus 16 times 2. If I add that together, I get a molar mass of 46.01. I know from the original problem that the compound had a mass of 92 grams. Okay, the mass was 92 grams. I'm going to divide that by the molar mass of my empirical formula, which is 46.01. That's going to give us a multiplier of 2. Once the multiplier of 2 is known, we're going to take that multiplier and go back and multiply our empirical formula by that multiplier. So again, our empirical formula was NO2. If we multiply all of that by 2, we end up with a molecular formula of N2O4. And so the molecular formula for this compound is N2O4. So again, in order to find the molecular formula of a compound, the empirical formula needs to be known. If it's not known, it needs to be calculated, and then you can find the multiplier to determine that molecular formula.